And I just actually myself learned about the closed captioning option because accessibility is a big thing in education. So you want to make things accessible so if people can't hear well, they want to be able to see. And I actually learned something else too from a conference recently that if you do put words on the screen, like so for captioning, it's actually better to not have the sound at the same time because it makes it harder for people to understand. Which I was like, that doesn't make any sense to me. But if you notice, if you watch any TV show with closed captioning, you'll see the subtitle goes at a different pace. Usually the subtitles go faster, or the captions go faster than what is the words being said on the screen. And so my sister used to complain about it because I used to turn on all the TVs because I used to love it. I don't know why, but she used to complain about it because she's like, man, the captions spoil the TV show. Well, there's a reason for that. They did some research and found that same thing I was talking about when I went to a conference. They realized that it's actually harder for people to read and hear something at the same time. Um, and so you want to speed up the reading a little bit, or have just the reading, or have just the sound. But the issue is that these are accessible if you have just the reading. And then the other issue with that is everyone can't read, so the sound becomes necessary. So just a fun little fact that you may have to deal with sometime in your future. Even if you're not a teacher, sometimes you still have to do things um, for accessibility purposes by adding captions. So I'm glad that you found an immediate use for that with presentations. So for this week, we're gonna be looking at two things: hardware and software. Now there are two courses at our school that deal with this. The first one is BPC 170, which deals with the hardware components of a computer, and then BPC 270, which deals with the software component. So mainly the operating system, and then how do you get the operating system to tell the other software how to work, and then installing that operating system and maybe doing it on multiple levels. So like if you have multiple computers in the classroom, how do you do it on one computer and have it go to the others? How do you do it on a main server on a network and have it go to the others? Things like that. So and those two classes, if you take them, they'll prepare you for a certification known as A+ certification. A+ certification is what's recognized as you know how to do computer maintenance. You could build a computer. Now, some of you in this class have actually already built the computer in your lifetime, and some of you may have seen it done, especially on like YouTube and stuff, because it's actually not as difficult as it used to seem. Um, there's a lot of wanting to make sure things are very clean, so you don't get any as many dust particles within your machine because it can cause damages, and then having certain parts. But yeah, people have been doing it for a while now. I've been doing a little cool mods. There's a couple of people who overclock their computers, which we'll talk about hopefully in this week if I remember. Actually, I'll just talk about it now because I probably will forget later. But overclocking is when you have your computer run so fast and for so long with not a fan powerful enough to help cool it down. And it reaches a temperature that it can boil water. Actually, can go hotter than that. So some people will purposely have a portion of their computer, or they'll have it set up so they have two really, but one that will overclock and they can run a program that'll overclock it and they'll use that to cook in the morning while they're just like working. It's kind of funny to watch. So if you go look on YouTube, look up overclocking cooking, you may be able to find some funny things. But it's kind of cool, like the different things that we can do with the computer once we understand the basis of how it's created, and then we can make modifications from there. So, but just like most things in life, before you can jump into the now, you have to look at the past. So we're going to look at the history of computers. Okay. So, well, I probably shouldn't have done that because I wanted to see what you guys are going to say first. So let me ask you all this. Let's hear that you can't see the top, although you guys can just go on your own computer and look on it on Canvas. But um, anyone have an idea of when the first computer was created? Anyone got an estimate for a year? You don't have to be exact.
I think 40s, right?
Did you say the 30s?
40s?
40s? Okay. All right. We got 8,000 BC, Benjamin. Okay. So we got something from like last century. We have something from 8000 BC, 1984. Okay. All right, some good estimates, all kind of all over the place in a way, right? Which is good because question really shouldn't be when was the first computer invented. Um, because I could say when is the first personal computer invented. I could say when the first computer as we know it was invented. I could
I
say
was
the
just
first.
gonna ask that. I was just gonna ask that. I was like, well, when you say the first computer, I'm sure like computers obviously back then like weren't what we deal with now, but it was still considered a computer. So it probably started like along probably like 1800s or something like that, like the idea or of a computer maybe.
Okay. All right. Yeah. Yeah. Actually, a little further back. So about what 8000 BC, like Benjamin was saying, you actually could probably go even further. They found new things that they found new um civilizations that go back further that have computing technology, and so that's where it goes from computer to computing device. So something that a device that is used to compute results, because that's what a computer really is, right? It can computes whether to have to give a number as a result or to give a 0 or 1. And so there are computing devices that go back way, way, way back. So like 8000 BC, 10,000 BCs, and some that could possibly go even further. I actually have one on me. Well, it's been, of course, made in a modern era with a 3D computer. So I'm gonna let's see, gonna come up in the corner there. So I have this thing here. It's called the Nepohoatson. Nepohoatson. And so it's really cool. Pretty much what you do is you can. Oh, I got this upside down. So what you do is you use this as a placeholder. So you have your 1, your 2, 3, 4, and then you go up here to 5, and then you come back down here in 6, 7. Anyway, so they would use this on my video, but they would use this for a calculator. And so when you were a kid, you would get one like the one I have there. They were just made out of beads and woods. So they would create that, and you could use that to learn calculations. Now, because of the way it's set up at the moment, I could go from ones, tens, hundreds, thousands, thousands, millions, billions. I can go up to trillions on here. By the way that it's set up right now. Now, I could also do those powers in binary, so I can go zeros and ones, um, up to the 2 to the 13th power, which goes to 8,182. Yeah, 8,182. I mean, you really think that's a lot, right? Especially like for binary and for way back then. And so they would also, as you got older, you get one that you just wear on your wrist. So it'd be a little smaller, be smaller. And so you would do your calculations really quickly this way. I have not figured out how to do calculus on here yet. I can do some pre-calculus. I can multiply binomials times a trinomial. For those of you that have gotten to that level of mathematics, you'll understand what I'm talking about. I can do multiplication, division, addition, subtraction with integers, with fractions. Um, yeah, I can even do square roots on here. We'll approximate a square root. So that's a lot for with just some beads that you guys saw, right? So most people probably see this and say, "Oh yeah, I can count. That's cool." Can you imagine doing all of that? This is going back to I think about 10,000 BC actually. But yeah, that's old. Like that's older than the abacus, which most people think of as like the first computing device. Some of you probably have seen an abacus before. Most elementary schools will actually keep one in the classrooms just so that students can see, and they'll say, "Yo, this is what we used to use for a calculator." When your instructors probably didn't use that as a calculator, but it's been around forever. They call it the Chinese abacus. Well, some people call the Nepohoatsons and the Mexican abacus. It's older than that, and it was in ancient native Mexican culture. I say native because, as many of you may know or may not know, uh, Spaniards came, and a couple other people invaded Mexico as well. I think technically the Chinese at some point did too. Don't quote me on that. I think it happened, but they came in, just like Europe did with everyone around the world. Came in and tried to take over. Same thing with China. They tried to come in and take over many places. Mesoamerica. Yes. So, yeah, that's a pretty ancient device, but it's a computing device. And like I said, there are others too. So what you'll see notice up here is that Miss Larita Moore, she's a professor at Southmont Community College. She has this thing that's called a tiki-taki, and it's pretty much you can use it to create a timeline. There's a link here so that you can go to it if you wanted to. We used to give out licenses for this for the students to use however they wished at the school. But there are a couple of different things she has on here that she's added to things that have helped. Things that have helped build technology or computing to what it is today. And that was actually an image of herself when she worked in a government office doing things. It's actually kind of funny. Her picture looks like one of the most famous, I would say, computer scientists. She's the reason we have compilers now when it comes to programming. Her name is Admiral Grace Hopper. So any of you have ever heard of Grace Hopper? She was a woman, which was not as common back then, but she ended up being an admiral of the Navy. She was in charge of the whole thing. But she also created compilers, which allow our computers to take information that we get and compile it so they can be read in a binary language, ones and zeros. So he's been given the authorship of that. So, but yeah, it's a cool little timeline that goes through some different things here. And I personally, I start at a different place. So you guys can check this out. That's why this is here. Yeah, but I personally, myself, I like to look at personal computers when that really began, which you could consider Nepo-Watson as a personal computer, but Nepo-Watson didn't record it didn't record your entry, right? It didn't record it didn't record what you computed and what your result was. You would just see a result. Sometimes you can see both. Most of the time, you'll just see a result, especially as you got into higher things. Well, let's start with the Pascaline calculator. So Blaise Pascal, awesome first name, right? Can you imagine being called Blaise? But Blaise Pascal, famous mathematician. Some of you may have heard of him, like Pascal's triangle, for instance. It's a big thing people use for doing binomial expansions. He's also did some study in physics on pressure. That's why it's called pascals. So some of you may know like pounds per square inch. Well, there's another thing for it, and that's pascals. So he's done a lot when it comes to math and science. But Blaise Pascal, when he was a kid, he would help his dad sometimes. His dad was an accountant. And so those of you that are in business and are in accounting, those of you that have ever had a job, you may or may not understand how much math goes behind it. And usually it's just a lot of adding, subtracting, and multiplying and dividing. And all depend on what kind of job you have, what your income is, how much you owe in taxes, how much taxes have you paid, and things like that. So, but this is back in the 17th century, so 1600s. Okay. So his dad was doing all these calculations like, hey, it would take a while. He wanted to help him, and he's a teenager. I think he's about I want to say he's between 12 and 16. And he's like, you know what? This is stupid. I'm not gonna sit here and do all these by hand. I could just make something, do it for us. And so here it is. I think he ended up making like 14 of them. Don't quote me on that. He made a small amount so that his dad and some of his dad's friends could do it. And that way they got more business because they were doing the calculations so quickly. And then it was less room for error as well because of how he created it. And so what he did was he took these gears, and he had like tape I say tape because it's not like sticky tape. Tape is just like rolled up. I don't want to say paper either, but rolled up material. That's what tape really is. We just think of sticky tape. That's why it's called that, because it's rolled up, sticky material. But he just had this tape, and on the tape he had numbers, and the numbers were put on there, written on there. Actually, you can even kind of tell still, maybe even from this image, that they don't look all the same. But he took these and put them around the gear so that as you so on the outside of this will be little knobs. So as you turn them, you could put in your numbers for the numbers that you're using. You could put in your operation, and then the result over here would get turned on its own because of what you're turning. And it's really, really cool when you think about it. And so he did that when he was, a teenager. And that idea of having numbers automated based off of this pattern that you see here, when it comes to addition, subtraction, multiplication, division, is one of the things that led to computing today. So let's look at another big involvement here. Jacquard Loom. If any of you have ever read the graphic novel series Wanted, or have ever seen the movie Wanted, Morgan Freeman, Angelina Jolie, some other random dude that's really the main character, but I guess he really didn't make any other movies that I'm aware of, because I don't know who he was. But anyway, they had this whole thing where the Loom would tell them the future and who to kill and all that stuff. So that's what that was about. But the Loom. So the Loom was created by Jacquard for one reason and one reason only. He was a weaver. And so can you imagine making all these great patterns with stuff, weaving, and people are like buying your stuff, and then, someone goes to someone's house and they come over to you and be like, hey, you made this cool rug for my cousin. I want a rug. All right, cool. I'll make something nice for you. He's like, no, I want the same rug. Okay. I don't really remember what it looked like. I'll bring it to you. And still, you're like, I don't know if I can make that the exact same, because you're weaving out different patterns. And so what he realized was that what he could do is take these wooden pallets, and he could punch holes in them. And so he can have the loom pass through these based off of where it saw a hole, and it would weave it for him. And so one, it made his process faster. He could sell more. But two, he was able to take these patterns, and then if someone wanted something different, he could just make a new one, or he realized he could rearrange these himself to fit into what it is that he wanted. And they still use this technology today to create these as well. So yeah, so all this was basically punch cards, or hole punches within some kind of car. In this case, these wooden pallets that the brain could weave through. And this is how we actually read and record data now. We don't have punch cards in our machine, but this idea is what led us to be able to do that later, because that's all this is doing. This machine here is going through and it's reading, oh, this is the card, this is how I push things through. That end result, that carpet or whatever that was threaded together, that is the recording of the data. So, then we go to Charles Babbage, which is known as the father of computing, which I totally disagree with, because he did everything in theory. He never got a working model. He never finalized even a model. But here it is, the Babbage Analytical Engine that's up here. And so what he did was he took the idea of Pascal with the gears, which I guess you could technically say is actually part of the Loom too. The alternating of changing a gear in order to have a certain thing occur. Well, that's kind of what the Loom does, except it does it with punch cards, right? You put it in certain spots, and then it alternates what's being done. But anyway, he took these ideas and he created this analytical engine. So the idea behind it would be an automatic calculator, so no need of having to turn gears or anything like that. You could just put your initial inputs in, and then it will give you an output. So kind of like the Loom, right? You put your inputs in, that would be the holes in the card, and then the output would be the product that's created. So he got all this together, or theorized this, but he didn't make it. So some of you that have taken English classes in the past or that are into poetry may have heard of this guy named Lord Byron. Pretty famous. Well, he had a daughter named Lucy Lovelace. And they say she was in love with Charles Babbage. But she was a student of his, at the least that we know of. And what she did was she, like, everything that he came up with ideas, she would just go out to try to prove it. That's why people say she was in love with him. She like worked really hard to like show that things could be done. But she was a mathematician, as he was too. But she would show these things could work, and then when he died, she continued on, and she was actually the one to create this first prototype of the analytical engine. So Lucy Lovely. So really should be a woman of a mother of computing. But a lot of people give it to Charles Babbage, and she did as well because that's the person that that was her master. That's the one who trained her. That was her teacher, and possibly the man that she loved that she never got to give that to. But anyway, so he designed this to print says star tables to predict star movements and behaviors. Components of this invention led to the development of short-term memory storage. So random access memory, or RAM, which we'll talk about a little bit, and then the central processing unit, or the CPU, and the idea of input, data being entered, and output, how it's presented. And so these four things, storage, processing, input, and output, are the type of devices that you need for a computer. So many of you probably can think now, just by me saying that, my computer does have storage. I have memory on my computer. You have a couple of different types of memory, probably actually. A CPU, central processing. You have something that processes data in your computer. Inputs. How do you input data into your computer? Outputs. How do you receive the data once it's been entered in and some calculations have been done? So now we're getting to Hollerith tabulating machine. And so this guy, Herman? Yeah, okay. Herman Hollerith worked at the U.S. Census Bureau. Some of you may have been getting a bunch of text messages and emails and phone calls from them lately. So, Census Bureau, government, if you're watching, yes, I am a black male who has already finished his stuff, so please stop calling. But the Census Bureau, so what they do is they collect data across the country. I think at one point in time it was more randomized because they realized they couldn't get everyone, but then they started trying to get every single person. And the purpose behind it is to have all this data so they could do certain calculations and decide on where funding goes, is one thing, for school areas and for state governments too. So how many of this type of people do you have? How many of these things do you have? They can do all these calculations on stuff, and then it gives them data on every person, like where's their current address and things like that. There's a lot of things that are here. So yeah, so you would send these letters, and that's what it would do. But they had people that would record all of this information. Like literally, they had to record everything that was being done. And so this guy Herman Hollerith, understanding Babbage's analytical engine, he's like, man, I could take that, and I could take the idea of Jakara Loom and just create punch cards. So what I'll do is literally the cards that came in from the census, what he did was he set them up so that they could be his machine would go in and read where something was darkened in, and it would punch through that into the palette in the back. And then he could take that and feed this into the machine here, and it would read where the punches are, and then it would output stuff with these little knobs here. It would turn to certain outputs, but all of that would get recorded here and saved here. So that's what he did. He created a tabulation machine. So he did all this for Census Bureau, and then his job was like, hey, make more of those. That's cool. That's making things a lot faster for us. So he's entering all this data in really quickly. There's actually one of these that still exists in California. There's the History of Computing Museum. I forgot what it's actually called. I want to say it's in San Francisco, San Diego. I saw it on if any of you, well, may not. There's a mathematician by the name of Matt Parker. He travels the world sometimes, and on his stand-up maths, the name of his YouTube channel. But he went there once and showed some different computing devices, and they actually got to play with because there's a few of these left and work, and so they got to actually play with it to see how it worked. He was actually on the 2.0 machine, which the way it took the data from punching cards was a lot cooler, in my opinion. So the cards are already punched, and then you pull the lever down on top of it so it would know where those readings are, and then it would hit electrical points. So kind of how your keyboard works. It hits something that sends an electrical signal to tell you that this is what this is the data that's been entered. So that's what it would do. It was really cool. But just watching it, that was the 2.0 version of it. But anyway, Herman Hollerith, after he did this, he left his job because he was like, I can just make a bunch of these to do anything, right? Which makes sense. Right? All it is just create a machine to gather information, and then it outputs the information and saves it. And so he's like, you know what? Any business can use this. So I'm going to call this business machine, the business machine. And so he started selling his stuff all around the world. And so because of that, he decided to name his company the International Business Machine. And later, that was kind of long for people to say, so they started calling it IBM, which many of you may have heard of. IBM. So IBM was started from this. But yeah, of course, I have a couple of links here, so you can look at some other things. Now, let's get more into the personal computers, or more into what we're closer to what we're used to when we think of a personal computer, because that's kind of big still, right? That hard top-line machine. Imagine having that in your living room. So, personal computer, the Altair 8800. This has been known as the true first personal computer, based off of what we think of computers nowadays. And so it had no mouse, no keyboard for input. That's a hint on what input devices are. So what you do is you would use these switches to give it pretty much on or off, yes, no, 1, 0s. And then based off the switches that it gathered for input, it would give certain outputs, and outputs would be light bulbs that would go off. So to let you know, and it would kind of like a lot of times people do it as like Morse code, because it would blink in certain intervals to let you know your result. And so, yeah, so using switches for inputs and then the light bulbs for outputs. And so this was actually where some programmers, so let me go back a little bit. So programming had been around already for a while at this point. I want to say, like, when I say programming, I mean like entering things within one language and having the computer output results. But the computers were much larger, of course, back then. So only like companies that had a lot of money, like the U.S. government, could do things when it came to computing. And so the personal computer here, it was the first time you could do something at home on your own, and it cost a lot of money back then too. And so, because of it, they were actually they were able to create their own computer language, programming language. And so they created what's known as BASIC. So it was beginner all-purpose symbolic instruction code. So you're writing code. It's called beginners because it's supposed to be for beginners, because there was other languages that were a lot more complicated to work with. But this was pretty much it would do as read. So it was a lot easier to understand. So this for x equals 1 to 10, print hola Wikipedia, next x. So that's pretty easy to understand, right? So you're going from 1 to 10 on x, and every time for each one of these, you print hola Wikipedia, and then it goes to the next x. So it just keeps looping through that. And so here it is. Prints out hola Wikipedia 10 times. That's pretty standard, pretty simple to understand, right? That's basic. This is the basic computer language or programming language. So yeah, so that was used within the Altair and created with it to make it even better. And then these two guys, well, there are a lot of people around the world that would have these and they would do some cool things with them. But these two guys here really took these by storm, and then they created a couple of different programs. So I'm telling you, this guy's name here, his name is Paul Allen. So you may have heard of him. He owns a company now. I can't remember the name of, but they do some pretty cool things. So he's one of the great computer scientists, I guess I should say. And if it was not for him, we wouldn't have many of the things we have today. The other guy, yeah, let's talk about him a little later. So these two guys got together and they created a program using BASIC that was known as a compiler. So a compiler, again, Admiral Grace Hopper was the one to first do that. So what it does is it takes the user's commands and translates it to zeros and ones for the computer to understand what it needs to do. So you take this language, compile it, and then the computer understands it as zeros and ones. So that's how programming languages work. There are other things called an interpreter, and so what it does is it takes the language and interprets it. Zeros and ones. Compiling is better though for your machine. Anyway, so this made use of computers in creating one's own programs easier and more fashionable. It was so popular that Altair developers decided to buy the program and release it to their future products. So the program that these two guys created was used, and so they decided to start their own company where they created softwares or these programs to do, tasks and make them a lot easier to do for these little tiny computers that they call microcomputers. And so they were making software for microcomputers. And so they decided to name their company Soft Micro. And then they said, no, that sounds stupid. Let's call it Microsoft. And so, yes, this is Paul Allen and the guy that most people affiliate with Microsoft, Bill Gates. And he was a tiny little man. So I do have something with her. So Amazing Grace Harper, Admiral Grace Harper. I'm going to open that up if it's going to go in Wikipedia here so you guys can see her face. Here's Admiral Grace Harper, person that created, as I mentioned before, the first compiler. So, yeah. All right. So you already can see Apple, so you guys probably can guess where we're going to. So two guys, just like these guys are two guys, Paul and Bill. We got two guys named Steve. That's what name their company. Two guys named Steve. I think that would have been better than Apple. They got together though, and they decided that in their garage they would create a better computer than Altair. So notice here, these guys are looking at computers that are already been created, and they're making software for them. These two guys are taking hardware and creating hardware. So how the computer is going to actually look. And so they created this guy in the garage. They called it Apple because Steve Jobs was working at an apple orchard. And he said that they were the perfect fruits because they had so much nutrients and they could not, they weren't as easily damaged. And so the computers they created would have everything they needed and they wouldn't be easy to damage. And that was his motto for them. So, yeah, that's why he called it Apple. Well, the cool thing about this was that Steve Wozniak was able to take those programs and the softwares, which these guys up here were creating, and put them on floppy disk. Because the thing about it was that when you created your programs before, what would actually happen is that you would create it, you do all these cool things with it, and then you shut down your computer for the day. You come in the next day at work. First thing you do at work is you would create that exact program again, do what you need to do with it all day. Then, okay, time to go home, shut it down, come back in the next day, turn on your computer. Guess what? That's right. Start all over again. You would have to recreate these things over and over again to keep using them. And so what he did was he created a storage device known as a floppy disk, which he was able to keep the software that would tell the computer how to run and save it out externally, so on these floppy disks, and then he could enter those in, and that's what was known as a disk operating system, which is what we use all the time, and that's what tells the computer how to process the other programs and things that it's going to do. So that was created by Steve Wozniak, and so that came with these Apple computers. And so the Apple II was their first chance here to actually get it out with a color monitor, because color TVs were getting popular again, very expensive too. He also took for to use as a mouse. He had game paddles, which he used to work at Atari. Steve Jobs did, so that's where he kind of got that idea from that. Some of you may know what an Atari game system is. I have one. Should show it. If I knew where it was right now, it would kind of cool to look at. But it also has some programs already set in there. So with the use of floppy disk, he could have the first. My dad still has his. Yeah, that's first system. Just because it's kind of cool to have a little piece of history with you. I think that's the main reason I think it's so cool. So they had word processors and a spreadsheet program, which were two things that people would most likely use in the world, especially in the business world. You want to type things, you want to save your data in the spreadsheet like format. But so they had on these floppy disks, you had the operating system already there, you had a way to store things, read only memory. So everything was already there, and then you could add other floppy disks in to run certain programs, such as the word processor and the spreadsheet. And so this is what they were able to do. And IBM wanted to do something with this because they're across the whole world, right? They're international. They see how these machines are changing their work, and so they want to do something just like this. And Apple is not about selling products to anyone else, any other companies. They don't want to give anything for anyone else. They don't want to make anything special for anyone else. They're all about themselves. That doesn't change. But IBM decided that, well, since you guys want to do it, we'll go get those guys that have been doing that other stuff with software. Those Microsoft guys, we'll have them create an operating system for us. And so they did, and they called it MS-DOS. Some of you or some of your parents may have talked about MS-DOS before, have seen it. FedEx, at least within 5 years, I know they were still using MS-DOS to record data. It's really cool, actually, to see. And actually, most restaurants use it too on the back end to like handle, to enter in like a new employee information or to terminate an employee. A lot of people still use MS-DOS for that. So, yeah. Okay, let me move on here. The Osborne. So there's a lot of history here. We'll get to some stuff with hardware too. Don't worry, in software. But there's a lot of history that I kind of want to go to because one is a part of our outline for the course by Maricopa to kind of understand a little bit of the history. But two, it's kind of a good way to see like this is where we came from. Like look at this first personal computer where you could just carry around. So it was portable. Called the Osborne. Look how tiny that screen is. Can you imagine carrying this around a day? They had one of these at that museum too I was mentioning in California. But it has these floppy disk spots as well. Have a keyboard. I mean, it's pretty cool. And you do have this guy. So you could walk around, go to work with this guy, and it weighed, I think, about 25 pounds. Yeah. A 5-inch screen, 25 pounds. Everyone bought this, right? No, I mean, a lot of business people did because it was cool. You could take that computer to work. You can take it back home with you. So kind of the first idea probably of doing a little extra work at home. Wish they never did that. All right, so Osborne created. Then IBM finally has their own computer that they call a PC because this idea of having personal computers, right? Starting all the way with the Altair 88. It's really popular. So they wanted to create personal computers for their businesses. So people that had that bought IBMs, that bought business machines. So with the help of Microsoft, they created this. So Microsoft created their own OS specifically for IBM. And so IBM called these personal computers PC because they're all about, acronyms because they're IBM, International Business Machines, IBM. So they have a personal computer, they're going to call it a PC. So technically, anytime anyone says PC, this is actually what they should be talking about. An IBM computer is the only thing that is technically PC. Just realized there I made a joke with the political correctness saying PC. IBM's the only is true PC. So yeah. So they wanted to compete though with Apple, and they said we'll sell ours out there too for a ton of money, and no one bought them because it was too expensive. Although IBM was very trusted because but Microsoft, just like Apple, with the whole idea of having the floppy disk, they created their own word process program and a spreadsheet program. So their word process program, they called it Word for MS-DOS. That name sounds kind of. And then they called the spreadsheet Microsoft Excel. That sounds like a pretty good name. Hope that stuck around. So everyone wanted to get into having personal computers now. So all these different companies are either having taking IBM's personal computer and making alterations to it, or trying to create their own, or they're trying to hire Apple, which Apple says no, you can just buy our thing, and get Microsoft to come up or to create their own operating system for them as well. So that's what's going on at this point in time. Then look at the screen still, and you probably saw with the Osborne and some of the others. You have this tiny text going across the screen, which is great and all, but what about what we kind of see today, right? We have all these little images we see pop on our screen, right? Even images that we can click on to make it open up other images. Really, that's all like the files for the web browser I have open right now. All of these applications are all just pictures, and then you touch certain parts of the pictures and it does certain things, right? Well, that's called a GUI, or graphical user interface. And the first one of these was created by a company solely for themselves. And their whole point was their whole point was to make things easier for their employees to be able to operate these personal computers. And so I usually ask the question, who created the way we use and see computers today? And a lot of people will say, "Oh, it's Apple because you just talked about Apple a bunch." Oh no, it's Microsoft because they made it for any computer. Well, Apple was only for theirs. This was actually made by a company known as Xerox. So many of you probably have heard of Xerox, or many of you have probably heard people say, "Hey, go Xerox that paper for me." And they'd use it as a general term for a copy machine, because that's what this company was mainly known for. That's right, making copies. So scanning papers and printing out replicas of them. That's what they were known for, Xerox. So they were a photocopying company, but they created this. And so they were like, everyone that saw this, I think it was like a public convention. I want to say some type of conference where showing like the newest thing with computing and with science. They used to do those called the World Expos. They used to do those in Chicago way back in the day. A couple of movies probably about that too. But anyway, so they would do this and they show people, and people are like, man, that's amazing. It would make using the computer so much easier. How much? And they're like, oh, this is just for all employees. Okay, I guess we could sell this. How about $17,000? And everyone's like, okay, if they had it. If they didn't have it, we're like, crap, I can't use this. And so Apple was like, haha, we know what to do now to make our computer even better. And so what they did was they created their own computer known as the Lisa, that had GUI interface, so graphical user interface, had the mouse hook up to a printer, had a keyboard, nice color screen and everything. And they said, hey, this is really great what we created. And so $17,000, we'll beat that. We'll get it to, like 9,000 something, maybe 8,000. That's still kind of expensive though. So eventually what they did was they were like, you know what, we can sell this for even cheaper. And so for about 2,500, which is close to the same price that they still go for today, they created the last version of their computer known as the Macintosh, which is where we get the term Mac from, just like the Apple, Macintosh Apple. So, yeah. If you go back and look through this, most of this all happened within 15 years. Okay. I'm more than twice that, and I have seen things flourish even more. Some of you, actually, all of you could say the same. You've seen just the computer itself, personal computer, change in so many ways that it's become even more flexible for any user to create on their own. You can buy a start kit for like $80 to do some basic computing with the Raspberry Pi board or Arduino board. Companies are sending these out for free because they want to see who's going to be the next Steve Jobs, next Steve Wozniak, next Paul Allen, next Bill Gates, come up with even newer ideas. I mean, if you look at operating systems that we use today, we have Windows 10, Mac OS X. Do you know why they have those X on them? Because they say that that's it, that's the end. There's no reason for them to ever come out with a newer version. It will be updates to the version they have. They feel like they've got it to the best that it can be. There's nothing else to do. But again, maybe new versions to just do updates. That's it, or not versions, but just to have updates. but everything is all X because it's it's the end of it. So what's next though? There are companies that create their own personal operating systems. I talked about POSs before, like in restaurants, but can you imagine having your own actual operating system that works specifically for you to do, you only have certain softwares that you use. What if it only worked on those? And so therefore it wouldn't have to worry about starting up everything else. It could go straight to opening up Google Chrome if you wanted it to. And that's it. Have nothing else on that computer. Say if you only use that. There's lots of different things you can do. So that is the history of computers. So yeah, there used to be a quiz after this on that. So all right, so now I'm gonna look at the hardware side of things. Before I do that, are there any questions? Oh,
You said that there was going to be a quiz on this?
no, I said there used to be a quiz on this. I don't think I think I got rid of it. I think I got rid of it this semester. Sorry, I didn't even need to mention that. Sorry. I forgot that I had gotten rid of it. That's why it slipped out. But yeah. So, any other questions about history? No? Okay. Oh. Think about that though, like oh wow, that's a lot longer now. So almost 40 years ago, the price of Apple computers have not changed. That doesn't make much sense to me. Oh, I mentioned earlier how if you look at how Windows got started, they took computers as they already existed and then added software to it. Look at Microsoft. That's exactly what they do still today. Like you can get all these different companies create these computers, but they have Windows operating systems on it, right? You have Microsoft Office applications, Microsoft different software that Microsoft puts out. But look at Apple. They started by creating their own hardware and then they added softwares to it themselves. They still do the same thing today. So Apple focuses mainly on creating their own computers. Microsoft focuses on taking those softwares and giving them out to computers. Yes, Windows, Microsoft has created their own hardware as well, but that's not as popular, and you will find those machines are much more expensive. That's why Apple's computers are so expensive. As people will say, well, why are Windows so cheap? They must not be good, or why are Windows so cheap? I'm going to buy those. That's because the Windows part is the operating system. Where Apple, you're actually buying the whole thing is their whole product. So that's why it costs more. So just so you know that, because I have heard people say that, Windows is cheap, so you shouldn't buy it because it's cheap. That's not true. Now, because it's not on the hardware created by them, it is open to certain security issues. And you can't say for certain the software works best with every device because it has to work on any device. That is why Apple seems to work such more smoothly, why programs can run faster, because they literally created the hardware that the software is running, their software is running on. So they know how everything connects. With Windows and like them working with HP or Asus or Acer, IBM, you can keep going with all these different companies, right? Like I can create my own company right now if I want to, and then get Windows operating systems on it if I really want to. Did I create the hardware to perfectly read the OS, for it to communicate perfectly? Probably not. Only people that can really do that would be Microsoft themselves. So that's why, like, if you buy Microsoft's like a Surface Pro or something like that, it works a lot better than if you just had like an HP computer or something. That's the reason why that's like that. But that's also why the Surfaces cost so much more too. They're around the prices of those Apple computers because again, you're paying for hardware and software together. That's going to work seamlessly coming from the same company. So that's something to keep in mind, especially as we move into hardware. So when we look at hardware, we're talking about devices that are used in order to do stuff with data. So we've already mentioned the 4 different types early on. So there are 4 different ways that a computer performs and uses data. First is to input your data. So input devices. The second device is a process device. So how does it process the data once it's been entered? The third thing, which third and fourth, they could probably interchange depending on what you're doing with it. But the third thing I'll say is output devices. So how do you receive back the result of whatever it is you did to process your data? Could even be just the entering of it into the computer. It gets processed, and then how do you see what you entered in? And then the last thing was storage. So where do you store that? So here's a video here. Go watch Mr. Ford's videos. If I ever put a video online on Canvas, definitely take a look at it. It will definitely help you understand things a lot more. That's the reason I put them on here. It's because of the amount of time we have in class too. So as we saw, I think it was week 1 when I tried to play, everyone couldn't hear, so that's why I'm not playing them. So okay, so I usually like to start with kind of asking you all about those 4 devices. So we're going to start with process though. So process, what components of a computer do you know of that are a part of their process devices? You guys can enter some things in the chat maybe. CPU, everyone's saying CPU, good. That is the most important part of the computer, honestly. It's the brain of the computer. It tells the computer what to do, the central processing unit. Oh, someone else put GPU. It's another processing device. Graphical processing unit. How do you see the graphics on your computer? Those of you that are gamers, you may have a very, very cool GPU. Some computers don't even have its own GPU to go with it. But if you do, what it does is it handles the graphics on its own, so it doesn't have to worry about putting a toll on the CPU to process that data. So, which is really cool. Like I said, especially if you're a gamer, you're going to want to have a good GPU. The motherboard, yes, and some of you may be able to see that on the screen now. The motherboard is where we're going to hold all of these different other process devices. And so the motherboard comes equipped with certain peripherals usually. No, it's at the school. So I usually like to show one to you all in class. Like you can look one up online. It's not as cool as seeing one live, but the motherboard will also have these little holes, or not holes, little let's say like little silver sticks that stick out, called IOs. And that also allows you to you can attach certain devices to it, so as you have more devices. You can do so with the peripherals as well. So like how do you put a USB into your computer? It actually is going through a peripheral that is attached to the motherboard, and so that motherboard then takes what goes in there and then sends it to the CPU, so it knows how to process and use it. So even your external monitors, those are connected. So if you have like a VGA or HDMI, those are connected to the motherboard as well. So the motherboard is the mother, so it holds everything, keeps everyone all nice and safe. Then motherboard tells the CPU, hey, CPU, you're the oldest. You need to go tell everyone else to get up, wake up, and what to do. And so the CPU wakes up and it tells everyone what to do. And they actually will get your software started too. It'll get the operating system started. So that's how I like to think of it. I don't know why. I guess because it's called motherboard. And yeah, my mother used to wake me up. But motherboard, CPU, the central processing unit. Like I said, it's the brain of the computer. Most of the calculations take place here. There's 2 parts to it. ALU, which is like is where the algorithm is done. So that's what actually takes care of the calculations, like adding, subtracting, multiply, dividing. Well, really adding and multiplying, I guess I technically should say, because subtraction is the same as addition, and division is the same as multiplication. And actually, it's all just addition. But anyway, it handles all that. And so the faster your CPU, the faster your computing speed will be per overall. So read-only memory. So when they created storage on a computer, Steve Wozniak, what they realized is that it's probably best to Instead, like I said, they were coming in and having to recreate a program in order to tell the computer how to run every single day. Right? That was that operating system. So they had to do that every single time they turned it on. So I shouldn't even say every single day. Right? Can you imagine like you're working on it and then the power goes out? Your power comes back on, you have to literally start from the beginning. You can work for 8 hours straight, or it could have been working for 3 hours, even still. You have to now recreate that. And so what they decided was they had two different storages. Well, three really, but two that the computer would be using. The first would be read-only memory. And so the CPU, being the oldest and in charge, it goes over and says, hey, ROM, time to get up. So ROM is where the operating system is held. Some other very important software that tells specific things in the hardware how to run. For instance, for your screen to come on, what comes on the screen, that kind of thing. So, and there's other stuff too, like for your fan to start working. But this is the non-volatile, so non-short term, the things that need to be on there and be there permanently. It should not be tampered with or deleted. The ROM holds this memory. And so the CPU gets up and tells the ROM to start working. The ROM will start those specific softwares that tie to certain pieces of the hardware that help your computer run. And it also says it gets the operating system started. And so once the operating system gets started and it's good to go, that's when everything else on your screen loads. If the operating system was not functioning, your computer would not be able to tell the other applications how to work. So if you clicked on Chrome, it wouldn't know what to do. The operating system is what handles that. It's kind of like a chain of command. The motherboard holds all of this, but the CPU is where everything really gets started, and then it goes to the ROM to start the OS. And the operating system is what tells everyone else what to do afterward. So there's other things on here as well. RAM is the second most important storage and memory, and what this does is it stores temporarily what's going on. So it stores anything that's currently running or any data that's currently being used. That's stored there. And so it is volatile, so it is very temporary. It can be read or written very quickly in any order because it's so temporary and it's because of the connection it has. But if you have anything in RAM, if you turn off your computer, say on accident or something unplugs, I remember one time when I was in college, I accidentally stepped on the power strip, the button that turns it on or off. I was so pissed. I lost everything. I was like, oh, well, autosave. Well, I didn't realize how autosave actually worked. It puts everything in temporary memory through RAM. And so unless it actually fully saved, it was gone. I didn't know that at that point. So I actually had just finished my project when I accidentally pressed that button. I lost everything. I had to work for another 8 hours. But anyway, it's a good thing to know then that RAM loses everything. Okay. All right. I have video card on here and network adapter. The reason I put these on here, because there's other things, tons of other things you can add to process devices you can add to your motherboard. So I mentioned the GPU, but I mentioned this on here because this is how we see things on our computers by standard. You got a GPU, what it does is it's able to handle the graphics on its own. And so it can handle those processes for graphics on its own. So therefore you get better imaging, faster as well. So like if you're playing a video game, things update a lot quicker and it comes in clearer as well. Because it's not having to do as much work. The CPU is not having to do as much work. The GPU is handling most of it. Network adapter, the reason I have this on here is because this is also very important. How does anyone do anything with a computer nowadays? They connect to a network. The network of networks, they connect to the internet. So it's very important to have a network adapter that will handle this for you so that you can connect to any network that you need to. So that's a process. Any questions about different processes? Honestly, the most important thing is the motherboard, the CPU, ROM, and RAM. Understanding that one is non-volatile, meaning it won't disappear on its own. The other one is very volatile, and it'll be gone once you turn off your computer. Yes, non-volatile RAM does exist. It does not read and write it does not read and write as quickly. And it takes more to work, so it's not as good. But if you don't want anything to disappear, then it's probably something good to have. So, and then of course the network adapter. You want to have something that's up to date so you can connect to any network. The next, I'm ask about storage, and then that'll probably be it for today, and we'll continue on Wednesday to finish up the input and output devices and talk about some applications. So I do want to start off asking you all, what is storage devices? What storage devices do you know of for a computer? Think about that word, storage. Go ahead.
Like flash drive, like clouds?
Yes, flash drives. And you say cloud? Is that what you said?
Yeah, cloud.
Yeah. The flash drives in the cloud. Boom. That handles really everything. There's different names that people use for flash drive. Like memory stick, USB, things like that. Although USB is the peripheral device you're actually going into, but that works too. And there's a reason that's a good name for it. USB stands for Universal Serial Bus, which we will talk about a bus system, I think, a little later when we talk about networks more. But yeah, so, thank you. Someone else added the hard drive and the solid state drive. Those are actually where most of our memory is stored, because that's directly on the computer. That's why you have external hard drives as well. But the most common thing that people think of nowadays are going to be the cloud and the USB. Yes, OneDrive for Microsoft, that is an example of a cloud-based storage. So I'm going to go to the storage page now. So first and foremost, our hard disk drive or hard drive and our solid state drive. This is where majority of your memory is going to be. The difference between these two is that the hard disk drive is, like it says, disk is in the name. So what it is it's a bunch of disks that are on top of each other rotating, that have different data read, that can be read from and written onto. And so it has a ton of storage. The issue with this is it's mechanical. So what happens when eventually it starts slowing down or no longer spins? It's done. Everything you had on it is lost forever. Because of that, they decided to honestly just kind of take the idea of what you do with the USB, but have the same similar components with the hard disk drive. So they were able to create what's known as a solid state drive. They call it solid state because it doesn't move. It doesn't have that mechanical part. And so it's less likely to break, if someone runs into it or it's dropped or something like that. But it works just like your like a USB does, honestly. So because of that, though, it's a lot more expensive. Some of you that see SSD or solid state drives versus a hard disk drive, you'll notice that it's a lot more expensive. And the amount of memory that comes on these for the same price is a lot less. So if you get one, you have to kind of think, how much memory do you actually need on your computer? But like one, for instance, but it does also, because of that, it starts up a lot faster, because a lot of your files and stuff, how your computer is imaged, that's saved on your hard drive. So if you notice that, like, you have a hard drive, you turn on your computer, it takes longer than a solid state. Solid state's like that. Like I have 2 Chromebooks that are pretty much the same. One has solid state and one has a hard disk drive. The hard disk drive, it doesn't take long because it's a Chromebook, so it doesn't have to load as much. But it may take like 10 seconds. Solid state takes like 2. And that's usually like if it runs into a possible issue in the beginning, that's what takes an extra second. Like it's that much faster. But the amount of memory, it's a Chromebook anyway, so there's not much memory on it anyway. But the amount of memory that I can store on there is a lot less for the solid state, because I wasn't going to spend that much on it. Cloud-based storage is the latest and greatest. Let me ask you y'all this: where is cloud-based storage stored? Is it really in the clouds? Servers, yes, good. I most of the time when I ask that question, people say it's in the cloud somewhere. People actually think there's like some big machine in the sky that just sucking up information. That is not what happens. Okay. Um, the cloud is just a bunch of. It's just honestly, the cloud is just a bunch of computers, which are called servers, which we'll talk about more later. This is a very large computer that can hold a lot of information. That's the cloud. Okay, so when you store things in the cloud, that's where it goes to, and those the cloud servers have backups, so which are more servers that are in other locations. And the reason for that is in case something happens to the main one, then they can easily get the data again, so you don't lose it. And so when it comes to storage, a lot of times people like to just have things in one place, like, oh, this is this thing, so I'm gonna put this on my USB. What happens if you lose your USB? What happens when your USB stops working? It's gone. Your stuff's gone forever. Okay. Oh, I only store things on the cloud. Okay, well, sometimes you may lose the rights to get onto it. You only can get onto it if you're on the internet or connected to the cloud network some other kind of way. So, okay, well, I only leave things directly on my computer. Your computer can't hold as much memory. What happens if you have a hard disk drive? That thing, someone pokes it the wrong way or accidentally touches it, punches it, drop it, it's gone. All your stuff is gone very quickly. So where should you store things? Why not all four places? Having a cloud service, so like with Google Cloud, I believe you get, I want to say 15 gigs. It might be a lot less than that. I want to say you get 15 gigs for free. So use it. You can create multiple Google accounts. You have your own computer, so maybe the things that you use a lot maybe have on there, but have backups of those files on an external hard drive. That's what I do, which just like another USB almost, but it has a lot of memory on it. But I also have it on the cloud too. So that way, it's less likely for things to be gone or to be lost. Another last thing that some people do, very, very, very important information. If you are writing a textbook, you don't want it to go away forever after spending 4 years on it. Have things stored in another location. So things that are very, very important, store it on another device and have it put in a safe in another location. I have a friend that has his most important information in a safe in Pennsylvania. He lives in Arizona. It's like if something happens on the West Coast, that's fine. His stuff is still there. So, of course, we have portable ones that we talked about, like the flash drive, USB, SD cards for like cameras, or you use them on your computer too, or your PSP, like I used to use back in the day. We also have optical storages, which most people don't even think about when they think of storage devices. That's right, your CDs, your DVDs, your Blu-ray disc, all of those are storing data. And so let me ask you all this: which one's faster, DVD player or a Blu-ray player? It's the last question of the day. Blu-ray or DVD, which is faster?
I'm gonna guess DVD.
All right. So we're like split 50-50. Aren't they the same? They are not the same. So they're the same in the sense that they are both optical devices. So they're both discs. It's actually Blu-ray that's faster. And the reason it's called a Blu-ray is because it uses blue light. A DVD uses red light, and blue wavelengths travel faster. Okay. So it's able to read and write faster. That's why those things are more expensive. That's why they started creating Blu-rays more often than DVDs. As you notice, they went back to having both because the DVD is easier. It's also cheaper for you to get them and create and for them to be made. So, but it does run slower technically. But how many of you are even recognizing that, right? There's also ultraviolet discs. I don't know if any of you have seen those. Those are even faster because ultraviolet waves travel a lot faster than blue light. So, yeah. So that's enough with storage. And then next week we'll look at input and output devices. Or not next week, sorry. Wednesday we'll look at input and output devices. Yes, blue and Blu-ray literally is the color blue. They don't put the E on there though because they want to be cool. Yeah. Like, what is that? I don't know. There's something else that's like that where they take stuff off because they want to be cool. But yeah. So we'll talk about input and output devices, and we'll talk about software. And then your assignment for this week, I'll go ahead and tell you what it is. You can kind of get started on it from what we talked about, is to think about your computer that you would like to have. Could be the one that you need for your future career. Could be for now. Could be, I want to be a gamer, but I'm also going to have this type of career. I'm gonna need 2 different hard drives to access, whatever. I want you to think about that stuff. Go online and see what you need to build it. See how much it's gonna cost. I will at some point throw a budget in there, but I always make it optional. I like for people to pick their own budgets to be reasonable. See how much it's gonna cost for you to build that. Or there could be a computer already pre-built that has everything that you think that you need. You're gonna have to be able to justify it though. So go out there and go ahead and start looking at that. The type of computer that you need. What type of process devices do you need? What type of storage devices do you need on it? What type of input and output devices do you need? What type of software will you need? So go ahead and get started on that. I will see you all on Wednesday. Thanks for staying 2 minutes over with me. I love you guys.
Have a good day.
Have a good day.
You too.
Bye.